Alright, in this video we're going to look at using pandas to work with data. Now, I'm going to be working with some data from a Pokemon website I scraped the other day. And ultimately we're going to try and make this figure over here. So, given the Pokemon type, can we sort of see the distribution of the stats for that Pokemon? Now, it's not material science, but it's at least a little interesting, if not a little artificial. But let's get started. Okay, so the first thing we need to do is when I got this data, I got it as a JSON. And it's saved as a JSON. In fact, if we come in here, I can open this up and show you all these different files. And this Pokemon data.json is what we're going to read in. And this is what it looks like. So it has a key representing some important value, and then a bunch of values associated with that key. And as we scroll down, we're going to get another key and more values. Okay, so you can think of a JSON like a crazy big dictionary. Let's go ahead and read one in. In our case, this JSON corresponds with tabular data. If it doesn't have the right shapes, you might get some issues, but we should be good here. So I'm going to call this df Pokemon, and it's going to be equal to pd.read. So we're going to need pandas before we can do this. So let me go ahead and do import pandas as pd, because we want to make a pandas data frame, and this one it's a data frame that's described by the word Pokemon, meaning it holds information regarding Pokemon. So we're going to do read JSON. Now, our data was in a directory, so it was in example files. I'm just going to go ahead and copy this. I'm going to paste it in here as our data dir. And whenever I make directories, I like to add this little / at the end, since I'm going to be adding another string to it. So we'll have data dir, and then plus, I believe it was PokemondData.json. I'm going to try and read that in, see if things went well. So we're going to run the first line in Spider, you hit F9 there. So when I'm on the second line, data dir, I'm going to hit F9. Let me just actually go ahead and restart this console so that we have a nice clean workspace. So I'll re-import pandas since I restarted the kernel. Here's data dir, that string. Then here's df Pokemon. Let's go ahead and inspect it. So we open it up, and we can look at what we're dealing with here. So the rows appear to have the Pokemon, and the columns appear to have information regarding those Pokemon. So we have attack, defense, HP, special attack, special defense, speed, and the total plus the type over here. Great. So now we kind of know what our data looks like. Let's go ahead and make an empty data frame that we can save things to. So I'm going to call this df rating, and eventually we're going to save the Pokemon's ratings to that. And we'll do pd.dataframe, and we're going to initialize a data frame object, but we're going to leave it empty. So what does that look like? Well, it's 0 by 0, and it has nothing in it. The first thing we add to it will sort of determine the dimensions it can take. All right. Now, let's go ahead and look at one of these columns, but without opening the entire data frame. So we can do df Pokemon, and then we can look at any given column name that we have in here. So if we go back to df Pokemon, we have the number, the attack, the defense, the HP, the name. All the way over here we had type. So let's go ahead and look at this. I'm going to close this. We can hit F9 to run the whole thing, and it's going to produce what's called a series. So let me go ahead and just call this Pokemon types. We'll hit F9 there, and we'll see it's a series as opposed to a data frame. This is a pandas series, and it's just one-dimensional, sort of like a vector as opposed to a matrix. Okay, now what I'm going to do here is it's a little tricky to work with all of the different Pokemon types. So I'm going to iterate through each row. So for Pokemon types in df Pokemon type, So what I'm doing here is I've made that series, so it's like a vector, and each item in the series I'm going to iterate through. Let's just for now do print Pokemon types. So what we have is Pokemon types. It took the value of the last item in the series, so it iterated through. So we erased the old variable name. Let's go ahead and just delete that. But we have Fighting and Ghost, and Pokemon types now has Fighting and Ghost because it iterated from the top. First time through it printed this, then this, then this, all the way down to here. Now just printing them is not important to us, so the next thing I'm going to do, I want to extract all the different Pokemon types, is for Pokemon type in Pokemon types, I'm going to say if Pokemon type not in types, so I'm going to grab all the unique ones, types.append Pokemon type. So now I need to make sure I have an empty list I can append to. And let's see what happens if we run this. We now get 18 different Pokemon types. And alternatively, instead of doing this entire for loop, we could get a little more clever. We could do Pokemon types, and we could do .unique. And what unique is going to do is going to grab us all of the unique values. And it's saying there's an unhashable type list. So I've made a little mistake here, because when we come in here and look at types, we have these lists in here. So that's going to be troublesome for us. Okay, well, we'll go with the loop then. So the next thing I can do is I can ask if a Pokemon has that type or not. So I could say for Pokemon type in types. So now I'm going to iterate through all the different types that a Pokemon can have. I'll say Booleans. I'm going to make a list with trues or falses according to some logic we can operate on using the Pandas data frame. So I'll say df Pokemon. So we'll reach into that series object. This was, remember, essentially just a vector with all of these lists inside of it. And what I'm going to do here is I'm going to tell it to become a string. So instead of being lists, be a string. So it converts to a string. And then finally I can say use a string method and ask if it contains the type that we're currently iterating through. So this is kind of long, so let me go ahead and make this bigger. Or even I'll add a little line continuation character and go ahead and tab this over. So this just means continue on the next line. Okay, so for Pokemon type in types, the first time through, we'll have the value grass. We're going to look through this entire column named type. We're going to convert that, so the lists, into strings, and then we're going to ask if those strings contain that Pokemon type. So the first time through it'll be grass. So Booleans is going to either say true, it has the Pokemon type, or false, that string does not have the characters, in our case, ghost, because that was the last item here. So let me go ahead and show you this part. Right here, the string had ghost inside of it. This entire thing is a string now because we converted it. And we asked if that string had ghost. And we got the answer true. Great. So now we know the type. What we can do is using that empty data frame, we'll go df rating. Let's assign some values to it. We will locate an index that we'll call Pokemon type and a mean value associated with that. So what we're going to do is we're going to build a data frame with a row corresponding to a Pokemon type and a column corresponding to the mean value. Now to complement this, it's going to be equal to, well, the mean value for that type. How do we get that? Well, since we're working with pandas, it's pretty easy. df Pokemon, we know because of this dot string contains that if our Boolean ends up true, then that row's string had that type in it. So what we'll do is we'll say df Pokemon, where the Booleans were true, grab an attribute. So let's say we want to know the attack and take the mean. So let me walk through that again. In this case, we'll save it to a variable. So we're grabbing df Pokemon. It's this entire data frame, 98 rows by 10 columns. That's this guy up here. And we're asking, give me the Booleans. So here, give me all of the rows that had the ghost type in them in this far column. So give me all the Booleans. So this case, instead of being, let's look at it before, it was 908 by 10. Now if we include the Booleans, so I'm running df Pokemon where it was true, we get 55 by 10. And then I ask for the column attack. And so then for those 55, we get that one column's worth of values. And then we can take the mean of that. So now, for the ghost types, we know that their attack on average is close to 80. So I'm going to go ahead and grab this for the mean. Let's go ahead and grab the standard deviation. And lastly, let's go ahead and grab the count. And so here, what we can do is, on DF rating, we can locate that Pokemon type. So locate a row corresponding to this Pokemon type. So we're going to define that when we first build this, or first assign data to this data frame. Remember, it's empty to start with. So we will locate the row named ghost and the column named mean, and we will assign it the value mean value. So we can do the same thing for standard deviation. So the row named ghost, add a new column named standard deviation and assign it the standard deviation. And then finally, in the column named, or in the row named ghost, in the column named count, assign it the count value. So let's run through this and see what happens. Now, I'm not going to go through the entire for loop. What I'm going to do is I'm going to go through the last part of the for loop. So right now, Pokemon type has been assigned ghost, which is the last item in types. So we have Booleans already, but let's run it again. So true means there was ghost in there. False means there wasn't ghost in this column here, types, when we converted it to strings. Now mean value is going to be the mean for all ghosts, the standard deviation of the attack for all ghosts, and the count for all ghosts. So let's go ahead and look at what count value looks like. So there was 55 ghosts, and we saw that when we looked at DF Pokemon with the Boolean, it went down to 55. Okay, so DF rating, locate. So DF rating right now, it's empty. We're going to locate, and if we can't find it, we'll make it a row named ghost and a column named mean, and we'll assign the mean value. So let's run that. And now let's look at DF rating. Let's look at our variable explorer to make it even clearer. We have a row named ghost, that's our index, and we have a column named mean. So when we go to this next line and run it, you can imagine we get another column, but the row named ghost now exists. So we'll locate the row, we won't see the column, so we'll add it. So we'll come up here, DF rating. We located the row, we did not see the column, so we added it. Then finally with count. And DF rating now has count as well. Okay? So, as we go through this for loop and look at all the different types, we're going to assign Booleans to decide if the Pokemon on that row had a type, or has that type. If it does, it gets a true value. If it doesn't, it gets a false. Here, using those booleans, we'll only select the rows that were true. We'll grab the attack values, or the column with the attacks, and we'll take the mean of it. We'll get the standard deviation and the count in the same way. And then DF rating, if the row doesn't exist, we'll assign a row with that Pokemon type. And we will assign a value to the column mean, standard deviation, or count. If it does not exist, we will make that column. So let's run it. First, let's erase DF rating by rewriting it with an empty data frame. So we're empty. Now I'll run the loop. Now we have 18 by 3. 18 different types, 3 different columns. Perfect. So we are almost there. So one of the things we can do at this point, and maybe before we do any sort of plotting, which is always good to do when you're trying to visualize data, is let's save DF rating. So you can do DF rating .to CSV, and we're going to save it to a comma-separated value sheet. And we'll call this Pokemon Attack Ratings .csv. Now if I save this, we're going to quickly open it up once I'm done. You're going to notice, where are we? There we are. We have Pokemon Attack Ratings.csv. You're going to notice the index, or the row name, doesn't have a label here, and that it is included in the saved file. If we don't want to include this, which is a little silly in our case, but it's oftentimes the case that you're using the index, but you don't want to save it at the end, we can do index equals false, and we'll save that. And notice I don't have any directory in front of the file, so it's saving the file directly into this location. Week 5, and then it's going to say Pokemon Attack Ratings. So let's come here. So here's the week 5 Pokemon Attack Ratings. And now the index should have been removed. So the index is gone. Okay. Now let's put that index back. And in fact, we can even give it a name. I believe we use index label. And let's call it type for consistency. And we'll open this last one up, and voila, we have both the index values and the label. So quickly, since I've said index 1,000 times, if we go to DF rating, the index is where I have these types saved to. They're not saved to columns like these 3 things. And you'll notice this data frame, when I look at it, says it's 18 by 3, because there's 3 columns and 18 types. Just to be clear there. All right, now lastly, let's go ahead and plot this. So I'm going to go ahead and create a figure. I'm creating a canvas with plt.figure. I'm calling this figure 1, and I want to define a figure size that's equal to, I like the look of 7 by 7 for whatever reason. So I'm going to go with that. Next, I'm going to use an error bar plot, and I'm going to grab my DF rating, and I want the mean values, and I want to plot those mean values against DF rating at the index, which if you remember was the types, and then I'm going to say X error, so the standard deviation in our case is DF rating standard deviation. Now we can go ahead and make it an actual error. I forget if this is the I think this is the 95% confidence interval if you use this standard deviation divided by the square root of the count, for those of you who are keeping track of statistics. And then I'm going to add a marker that's a circle. I'm going to make that marker face color MFC white. I'm going to make the marker edge color, I made a mistake here, the key shouldn't be a string. This is the argument name. A marker edge color is black, and a line style. So on my lines, I don't want to have lines here. And then finally, since this is an error bar, I want to add caps to it. And we'll go ahead and add a color to our error bar as well. Alright, so what does that give us? Well, it gives us an error because we forgot to import matplotlib.pyplot. So let's go ahead and do that up here. So we're going to import matplotlib.pyplot as plt. And that should give us the ability to plot here. Excellent. With one little mistake, we don't have numpy. So let's go ahead and import numpy as well. Import numpy as np. And if we're lucky, we get this. Okay, so what went wrong? Well, in the previous image I showed you, we had sorted our values. So we can add just a little bit of code that can update this to make it a little bit better for us. In fact, let me just do that right there. So this will show us sort of the shape with a bar plot. And then let's come back and df rating not mean, df rating index. Now that it's been sorted, let's look at how this is. Error container object. Well, I don't know what to say about this error actually. Oh well, sometimes mistakes happen. I'm not going to take the time to see exactly what went wrong there. Let me see if I can copy paste my old code. For Pokemon in types. And there it is. Okay, so as a last step, it is in fact sorting that I missed. So what we can do after we build df rating is for each of these, we can take our rating and we can generate booleans. So just like we saved booleans here by asking if the string contained the type, we can ask if df rating count is greater than 0. If it's true, we can take df rating at those booleans. So here are the booleans. Df rating at those booleans, so the rows where it's true, and we can sort the values by the mean. Okay, so if we run this, df rating now gets sorted. Let's go ahead and do that. Let's see if this is any prettier. And there we go. Ends up a little bit better. Now we did attack. If we do total, I think it's even more pronounced. Attribute. Let's call that total. And there we go. We get that nice little figure. Excellent. Okay, so we'll call this video here. That's a pretty long one. Knowing how to work with pandas is probably the most useful skill. Maybe plotting is as useful, but those should be, this next homework and the homework following should be the bread and butter of any good engineer. And the ability to do this will, it'll make you stand out. So good luck and make sure to learn it. Bye.